Welcome to the culvert test bed near Bacota, Washington. This is a facility that's owned by the Washington Department of Transportation, and it's on the grounds of the Skookumchuck Fish Hatchery. And it's one of a kind. It's a unique facility on the West Coast, and it's essentially an experimental flume that actually has the capacity to mount different size and different shapes of culverts within the flume itself. The beauty of the system is that you can test culverts of different size and different dimensions. It's a 40-foot length standard culvert that has to be tested. It can be tested on slopes anywhere from 0 to 10%. The amount of water that you can run down the culvert can go up to 25 cubic feet per second. And so the range of velocities that we can create through that combination of culvert slope, culvert size, and discharge is substantial. It was originally constructed with a fund that was put up by a consortium of transportation agencies along the West Coast from Alaska to California. They constructed it because there was a serious lack of empirical data about fish passage through culverts. And they were being challenged on a number of fronts for improving fish passage. The estimates in Washington alone for the Department of Transportation on state-maintained highways is close to $1 billion. We had originally wanted to seine the fish or capture them without using any electric current around them. However, this is a project that must be efficient as well, and we found that our ability to collect fish with a small seine, using it in a variety of ways, just was not effective and efficient in small streams. We use low current. We use about 600 volts, set it on 30 hertz, and a duty cycle of about 12%. And we find that these fish are swimming as soon as they hit the bucket. Sometimes we'll have sculpin as well, but most of the time it's just coastal cutthroat trout, a resident variety. We're primarily sampling 1+ fish, and the average size of our fish has been about 120 millimeters, and that's considered a 1+ age fish. So it's in its second year of full stream life and approaching breeding age. And so it's especially important that we understand the capacity of those fish, the performance of those fish to move through pipes, because often in the spring when they move up, they move upstream to spawn. And of course, when they do that, they've got to have free passage through the stream system. The issue itself is huge. It's huge monetarily. It's huge in terms of the number of road crossings that it affects. And it's huge if we don't get this answer right. The tests and the data that you derive from it rely on the fact that fish must move through it volitionally. That is, they're not forced to move through it. They're not encaged in the culvert itself and forced to move at any one particular time. The current round of trials that we've demonstrated on average 80 to 90% participation by these wild cutthroat. In 2003, we relied on infrared underwater imagery cameras to capture fish movements. And in 2009, that's the only technology we had to assess movement of fish through the pipe as well. And we sat there bleary-eyed all night long trying to see on a grainy 7-Eleven image the instantaneous movement of a fish into the culvert and then see its exit into the headwater tank. One significant advance that we've made in 2010 at this facility is the installation of a half-duplex pit tag system. And it has literally catapulted our results and our data well ahead of what the capacity of the facility was in the past using the infrared underwater imagery. The work that we've done out here so far suggests, number one, that it's possible to use wild fish in this facility. We can capture fish in the wild, bring them to the facility, tag them, and have a reasonable expectation that we're going to get good participation, volitional movement through the culvert to actually test their performance. Suffice it to say that we've seen movement of 1+ cutthroat trout averaging 120, 122 millimeters successfully through a pipe with an average bulk velocity of 8 feet per second. Now that's substantially in excess of what people assume from the laboratory performance of this same species. This is a $1 billion fix if you replace all these pipes, and there may be some very easy retrofits of pipes that are very serviceable and will be very serviceable for many years that will actually provide passage of fish underneath these roads. I think the significance of our work is simply that we're providing empirical data. We're actually taking a culvert, we're running water down it of a certain discharge, producing velocities of a certain range, and we're testing the ability of these fish to move through it.